So the focus of today's presentation really is Plantation Watch, as Dave said, or Landscape Watch I might use interchangeably within the presentation. But it's really sort of leveraging temporal data. So revisit satellite data over the same location and unpicking that signal to sort of work through trends. And in a way, you can sort of think of this as it's another tool in the forester's toolbox. So I think it's probably been overlooked a little bit. So what I'd like to demonstrate in this presentation actually is how you can actually use it operationally. But maybe before I start, I'll just introduce a little bit about Indufor. So you probably know Indufor better for our forest appraisal activity. So mostly within Australasia, we have that portfolio. But within the Indufor office here in Auckland, we've got a reasonable sized unit that looks at resource monitoring. And so that's a combination of skill sets really now. And I think it sort of reflects modern day forestry. You've got data scientists, computer programmers, and foresters. And we sort of deliver on three themes. So continuous monitoring of landscapes, providing resource insights, and precision forestry solutions. But today I'll just sort of demonstrate the monitoring landscapes as sort of a keeping on topic. So temporal data has been with us for a while. So Landsat was the first sort of landscape monitoring satellites that were launched in 1972. And what it sort of showed is in this video, I'll just play it shortly, it's about a minute long and it's got sound, so I'll be quiet while it's playing, but you kind of get the picture that you can monitor landscapes with repeat visit satellite data and sort of information you can gain from that data. So I think you'd probably all agree that that outcome really sucks. And it's quite devastating to see, but in a way, the value of the data has actually increased awareness of global change and habitat destruction, over the last 50 years. But the challenge, I think, also exists is how do you actually leverage that information? So how do you take it from being a picture that shows that massive destruction, the location of the destruction, to actually using that signal within an application sort of environment? So what I've got here is it's just a slightly where we've fast forwarded to 2017. Okay, so now we're in the world of Sentinel data. So that's the satellite that was launched in 2017, 2018. There are two of them in orbit. So you've got a revisit frequency of every 5 days and a resolution of 10 meters. But the cool thing is you've actually got a massive swath. So it covers large areas, so really good for landscape monitoring. And what we unpick here is actually, you'll see on the screen, you'll see this graph here. So I'll talk a bit about this graph and I'll talk a bit about this graph. And in the center of the screen, we have a plantation surrounded by farmland. So as I play the animation, we load up, sorry, I'll just pause there a second while it catches up. You look at the temporal signal here, which is the bumpy line here. So that's showing canopy cover at a certain point of time with vegetation index. I load the image by pointing on the graph for the first point in time. And you can see everything's okay. The plantation is still intact, the canopy's intact, the grassland's quite dry. Go forward to after a rainfall event. So I'm picking this point here. You can see, oh, okay, good. Plantation is still quite good. Canopy index is quite high. But if we fast forward in time a little bit to the 2022, so we pick up one of the latest observations, you suddenly see that the plantation has sort of lost canopy and it sort of started to collapse. So the point being in this one here actually is that using that temporal signal, you get quite a lot more out of the data. And you can see with a little animation at the bottom, and you probably can't see it, but it's timestamped. It's showing, cycling through the catalogue of images. So this is happening all in real time within the system. So that's good, but I'm guessing like you're thinking, oh, I'm not going to zoom around every area and draw a polygon around it and look at it. I need a way to sort of take all that data and then put it in a format where you can analyze the change. So we sort of came up with this concept of landscape monitoring framework. So trying to automate this process as much as possible, so you spend less time looking for this change, but you actually get an alert to tell you where the change is occurring. And the idea here was it had to be really scalable, so you could actually do it over large areas. So I'll introduce the MO system. So this is something we developed here at Indufor, and it's really designed to use that rich temporal signal, and it does that by basically pinging the satellite archive all the time to look for change. And the way you can do it in a scalable form is actually breaking up the landscape into hexagons. So you've got discrete units, which you're monitoring continuously. So you're monitoring every one of these hexagons every time you get a satellite overpass. And you might remember in the earlier talk by Cam Brown, they also use hexagons. Hexagons are really good shape to fit into complex sort of boundaries or map boundaries. And you'll see that they have some part hexagons. So these hexagons are, when they're full, they're about 5 hectares in size. And along the edges, they're a bit smaller. So in this case, we've just got a pretty simple example. It's a forest harvest event. And we're looking at full canopy here. And then suddenly we get a harvest event, an alert. So somewhere in that hexagon, something's changed. And the first alert is triggered. Second alert is triggered. And a third alert is triggered. So the idea here is that every 5 days, the observation comes over, checks against the baseline. If something changes, then you get an alert. And then you get, the more alerts you get, the more confidence you have in the system. So you have a lot less sort of false positives. So this is the concept here. The MO is running in the background, looking at the image archive all the time. As a new satellite image appears, it compares it against that baseline for all those individual hexagons. And then it's doing all the heavy lifting, really. That's kind of the concept. So once an alert is pinged, that's all you get. Because it's operating in the cloud, you're not downloading any satellite data, you're just basically downloading the alerts. And it's doing all the clever stuff as well. So it's screening for cloud, and it's to make sure that you don't get false positives sneaking through. And it's operating at the pixel level, so the 10-meter image, 10-meter pixel size, I should say. So that's all cool, but how do you actually put that into a monitoring framework? So you've got the two things I introduced at the beginning here. You've got Sentinel-2, which is we're using as the workhorse. We've got the alerts pipeline, which is the MO. And then we've got something called Landscape or Plantation Watch. And then we've got an online dashboard environment. So the idea here is that the Landscape Watch is sort of pitched at expert review. So people with quite a lot of knowledge of spatial data. And they would basically tasked with reviewing the alerts as they come through. And because they know their domain area, they decide whether they want to escalate these alerts and summarize them to a dashboard. And so the dashboard's really targeting people who perhaps are non-GIS experts, but it's pretty accessible data on the dashboard. It's just a web link. It's easily shared. And you can easily share and sync it to field devices. So that's the workflow that we sort of came up with and developed. So applying the concept. So we have a project actually over the last 6 months with Waikato Regional Council here in New Zealand. And they were interested in developing a scalable workflow where they could generate these landscape alerts across large areas. So the 3 districts that we rolled it out in are shown here on the map, and they're monitoring what we call significant natural areas. So these are areas sort of located on farmland or sort of hard and inaccessible areas. So it's very hard to actually get an idea of where all the change is occurring. And often they're quite fragmented in size, so they're pretty small. So the idea here was that we provide to the WRC team the expert app, so they can actually review the alerts and then push them through the dashboard. And in that way, they've actually optimized their workflow, and they have some idea of where the change is occurring and when the change occurred. So that's kind of the idea of the concept with the alerts. And by doing that, you actually build a bit of structure into a process, because previously it had been quite ad hoc, and the task with monitoring all sorts of land use change. It can be, say, spraying events on vegetation, can be land clearance, or could be erosion of fragments of bits of forest, or even agricultural draining of peatlands. So it's versatile enough that you're not looking, so to say, at large changes like forest harvest. You have to be able to have a system that can pick up quite discrete changes in vegetation. So I just play this demonstration here. So this is what the WRC team sees. As it loads up, it's one region, and the blue areas are all the SNAs, so they're quite small and fragmented, and they're divided up into hexagons. And the red spots are alerts. And on the right side, if I catch up with this, you've got the alerts as they come through. So it's pinged an alert here, and you can see the alert line here. You click on the before image, and it's got this highlighted, this small area here. You pick on the alert point, so it's only one alert at this stage, and it shows the land clearance. And so that's ranking up or stacking up all the alerts for that region, which they go through and review. So it's something that takes about an hour and a half every month for them. They then come down and they can decide whether they want to classify the alert as well. So they can say, escalate it to a fly, a visit, or no, it's nothing. So sometimes you see things like wetland changes, which are just seasonal changes. So drying up of wetland looks like an alert for a change. So they review that and say no change. They also get, for every one of those satellite images, the animation here, and it's date stamped. Sorry, we didn't. It's date stamped, and so it basically gives them the evidence that they're looking for. And if they choose to escalate that, they then push that to the dashboard. So that's what the compliance team would take forward and push it to an app, or go and visit it in the field. So it's going to streamline that whole process. So within the web app, it looks really, really similar to the expert dashboard, but it's simplified everything. So this is the idea here, that you let the experts decide whether they want to escalate an alert. And if they do decide to record it, they want to put it up onto a dashboard where everybody can actually look at it and decide what to do with it. So it's very similar look and feel. And the idea here is that you can share these really easily. So you can give it to the compliance team, you can give it to the field team, you can put it on a field-based app, and they can go out and take photos, and it can sync back. So for this one, we've got 93 alerts over 26,000 hectares, escalating some of these ones to fly. It pops the alerts up on there, they have to fly, or you can have all the ones that they have to visit. And within the map base, you can see that you can zoom around. It's the same very much functionality you see in a GIS. Click on a feature, understand what the feature is, and it's got basically the size and what type of feature it is, so what sort of land cover it is that you're monitoring. You can load all the base layers, so I'll put the alerts on. They pop up in the dashboard, and you can see that the red ones overlaid over the SNA areas are the alerts, and it gives you the baseline index that you're monitoring from, and the first alert index and the number of alerts for that particular feature. So, and you can zoom anywhere on the screen, basically, to query. And within this app, actually, you don't have the temporal sequence cycling through, but you have the before and after images. So you have some sort of, I guess, validation that something's happened here. And in this case, it's an area that's been sort of cleared, and all the alerts around it are quite clustered. So on private land, some land clearance activities happened. And sometimes it's quite legitimate, but you may know that from the context because the experts are reviewing it, or they may need to go and look at it. But the cool thing is that within this, you can load the alerts, you can load the baseline images, and all of the information required. It's very easy to obviously transfer to other people. So probably just changing gears on the next couple of slides, I thought it might be useful to sort of demonstrate some of the free apps that we've been developing here. So the idea here really is that I'll give you the links that within the presentation, but we found with various projects that a lot of uptake was being sort of slowed, I think, by people not really understanding how they could use such a volume of data. So everybody knew about Sentinel, but to download a whole Sentinel seems quite chunky. And you fill your hard drive up pretty quickly. So to offer a couple of apps that allow people to draw polygons. So the first one that we have is called Plantation Watch. And this is really designed to be able to draw a polygon on the screen, review all of the imagery. So underneath this one's all the collections from over basically a month, or 2 months, sorry, over Laos. So Laos on the right side and Thailand on the left. And you can choose what sensor you'd like. So within this is actually baked in Landsat. So the data the sensor that was launched in 1972, all the Landsat series. There's a radar sensor in there called Sentinel-1 and Sentinel-2. So you can choose which sensor you'd like to review, draw a box, scroll down the bottom, you can't do that here, and download that small snippet of imagery. So as a zip file directly to your desktop, and then throw it into the GIS. It's geo-referenced, and that's also includes the near-infrared band. The second app then, Stand Tracker Lite. So this is the one I actually showed you the demonstration of canopy decline. We've pre-baked in a number of different, case studies. So in this one, we've got wilding pine control. So an area in New Zealand, in the Marlborough Sounds, where they've been busy poisoning pines that have escaped from plantations. And you can see then that you can cycle through satellite data, and you've got the temporal signal here. And we use a number of different vegetation ratios to tease out the change. So this is full canopy, bang, they poisoned it and it started to die. And you might see a little bit of a tail come back, but that's the undergrowth coming back, not the tree crown. So the cool thing here is that you can cycle through the satellite imagery, as I showed you in the first slide. It's time-stamped. You can actually copy that animation and put it in an email, and it will play when someone clicks on it. So just a couple of slides to go, so not too much more. So some further worked examples here. So just sort of covering off some of the other things we do within Indufor. So obviously we've got a lot of alert sort of stuff going on with dashboards. So this example here is east coast of New Zealand, where we've been monitoring basically harvesting within the hexagons. So we've been doing that since 2019. And it gives you an idea of the rate of harvest and also the timing of the harvest. Again, this is public data, so we've gone and grabbed some boundaries from a land use map. So we delineate those, and then we just monitor within. So when a change occurs, it automatically updates the alert, and on the dashboard, it changes from, this is green, I think, and goes to red. And then it's continuously updated every couple of months. Sort of extending that one, you also looking at compliance monitoring. So there's a lot of stuff around at the moment in New Zealand, in particular on national environmental standards. So people wanting to understand change close to sensitive areas, areas like wetlands or streams. So in this case here, we're monitoring winter grazing on pasture through the winter. So again, it's quite good that you do have repeat visit data. That's every 5 days. You've got really good algorithms that can use just the individual pixels, and you've got a sensor that's really well calibrated, which is probably one of the other points. And lastly, I'll probably just point to some of the forest analytics, which is using, again, satellite data or LiDAR, but you can mine that temporal signal to understand how forest is changing over time. So you can actually get age class, for example. You can classify for area, and then just build up a forest description, as we call it. And we would shift that onto our forest valuers or forest appraisal guys to do wood flow analysis and software like TigerMoth. Okay, so this last slide, I'll just probably hand back to you, Dave. Any questions?
Thanks, Pete. Really good insights there. And yeah, we've got definitely time for questions there. So yeah, jump on to Poll EV and fire those through. The first one there, Pete, is does it monitor at a pixel level or the hexagon level?
It's actually doing it at the pixel level. So while the hexagons are 5 hectares, that doesn't mean that's the detection unit. So the detection unit's more around about a hectare in scale.
Excellent. And I've got one more there. How much does it cost the council per month to use the monitoring system? Might be a tricky answer, but I'll leave it with you.
Yeah, thanks very much. It's been, to be honest, it's a pilot project. So we've invested quite a lot of time in developing and actually customizing the application. So the money wasn't such a big deal here. It was more just to get proof of concept, which we have done. So they're looking to run this operationally across all of the regions in Waikato over the next year. So they're happy with it, and it's scalable, which is good.
Excellent. Oh, that's all the questions there, Pete, and certainly thanks for your time and great to get an update from the Indufor team.